A lot of times when we look at AI experts online, it's more people working recently on AI and also people working on chatbots, but you have a unique experience where you have worked on this before it was the hot thing.
Some focused on autonomous driving products, some around AI, specifically around deep learning inference engine. And one of the last areas I focused on was around GPUs or graphic processing units.
How is text generation different to image generation?
I'd say foundationally, text generation models tend to be transformer-based architecture, and they process text sequentially in the form of tokens.
It doesn't understand the physics part of things. And also, if I want to just change one piece of the image, which is, if I generate, I don't like something, I want to remove one person out of the image, it's not able to do that segmentedly. And also sometimes when there is text inside the image, that doesn't come out right.
One of the key things to understand about generative models is that they are non-deterministic.
So how did you guys go about thinking about metrics, then validating the hypothesis, and then finally telling, okay, this is the model that's working well?
For AI metrics, especially when you are in a 0 to 1 space, you kind of have to make them up as you go, right?
Right, are there enough methods to measure accuracy for some of the outputs that come out of these models now, or are they still evolving?
It depends how you define accuracy. So to me, accuracy is akin to...
What is your approach towards responsible AI?
There is no 100% effective solution out there today, not that I know of.
Let's say if someone wants to go into Azure and the hardware side of the generative AI, what are some of the tips that you could give?
The compute requirements for training or inference, that familiarity would have to be there.
Hello, everybody. Welcome to our podcast, Everything Product. So we talk about latest technology and product management concepts here. Today, we are very glad to welcome Anita Lacha. A technology leader whose journey spans out from Romania to shaping AI innovation in the US. After 14 years at Intel, she served as the head of generative AI for image ads at Amazon, now leading their first AI image generation system. So she brings this unique hardware and AI expertise to Microsoft as the director of hardware and infrastructure transformation. So Anita, welcome to the podcast. Thanks for taking time to talk to us today. Why don't you get started and tell us about your journey?
Thank you, Sid. I'm very excited to be here. Thank you for having me. Most of my career does span at Intel, where I had various strategic and technical roles. Some focused on autonomous driving products, some around AI, specifically around deep learning inference engine. And one of the last areas I focused on was around GPUs or graphic processing units. After that, I had the opportunity to move into AI leadership at Amazon. And I'd say that was more of an instance of being in the right place at the right time and making the most of it. And that's where I jumped into generative AI and bring it to market, the first non-chatbot AI, generative AI application for Amazon, and where I learned the most about the technology and what it means to build an enterprise generative AI product. Once you scale a product like that, the problems are still there to solve, but I'd say they're not as novel, one problem after the next, which is why I decided to shift to Microsoft. And during my time at Amazon, I also realized the importance of core technology in enabling the AI workloads, especially as more and more of the world is starting to adopt AI workloads, and that core technology, such as GPUs, but not limited to that, is crucial. And that's where I am today. And I'm focused on transforming, I'd say, the Azure hardware infrastructure to be well positioned as a leader in this industry for enabling business demands and future AI workloads.
Awesome. And we are also very eager to have you because a lot of times when we look at AI experts online, it's more people working recently on AI and also people working on chatbots, but you have a unique experience where you have worked on this before it was the hot thing, and also it's a little bit different than generative AI. It's generative AI images, right? Not chatbots. So let's get straight into the question here, Anita. I know a lot of people understand text generation and GenAI with ChatGPT, Claude, and all. Look, how is text generation different to image generation?
I'll try to take a high-level approach with the caveat that there are many nuances in the types of model architectures that address text generation versus image generation. I'd say foundationally, text generation models tend to be transformer-based architecture, and they process text sequentially in the form of tokens by understanding the relationship between those tokens. So tokens can refer to a word or parts of a word. And also the training data for the text generation models is text data. On the image side, the image generation models, one of the most common model architectures is diffusion models. And think of that as you're actually watching a photo being developed like in the old days with the red light. It's a similar process there where you start with, especially on the inference side, you start with random noise, and through multiple diffusion steps or reverse diffusion steps, you end up with the final image that we get to see. Image generation models, they deal with continuous data and with the relationship between millions of pixels that end up making that image. I'd say the computational demands for the two types of text generation and image generation models are also different. If we take models that tend to have similar sizes in terms of data and text generation, again, usually it is less compute intensive, while on the image generation side, it is very compute intensive, requiring a lot of parallel processing to process those millions of pixels simultaneously. In terms of challenges, both types of models have challenges, and that's known as hallucinations most of the time. On the text side, you can get incorrect text outputs. They may seem correct, but they're not actually correct. On the image side, you end up with things that are most commonly, 6, 7 fingers, for example. So there's not an actual understanding of the context. Text generation and understands context. That's what the relationship between tokens results in. While on the diffusion side, it doesn't have the context.
So you're saying that the fundamental differences for text, it's predicting the next character, but for images, is it predicting the next pixel? Is that it?
I wouldn't say it's on the image, correct on the text side, but on the image side, I wouldn't say that they are predicting the next pixel. Image generation models on once they're deployed, they do understand the relationship between text, which is the prompt describing the image, and the image itself. And that is, think of it kind of combing through the training data. Obviously, the training data is not there when deployed in production for inference anymore, but the model has learned. And once it starts the diffusion process, it looks to see if the image that is becoming more and more clear is relevant to what the prompt that the user inputted is.
Awesome. So sounds good. So most probably maybe it's relying on some weights which were set during the training
Of course,
session, I guess, right?
both models, yes, use weights. On the text side, they use they're called experts. Think of it like having skilled workers for certain areas, and that's how they work. On the diffusion side, we still have weights, but as far as I know, or at least my experience, didn't come across experts yet. Although there is the latest, one of the latest innovations, that's diffusion transformer models. applied for image generation. And that's where image models end up benefiting from the context that transformer models have.
Awesome. Sounds good. I think, yeah, I had a lot of confusion between all of this before, but I think you went through clear boundaries between both of these different technologies. But I see that, at least for text, I've used it a lot, and it's kind of getting better and better as we go. But for the image generation, right, what I've seen before is whenever I give a prompt, as you said, right, it might have a human with six fingers, seven fingers, and it doesn't understand the physics part of things. And also, if I want to just change one piece of the image, which is if I don't like something, I want to remove one person out of the image, it's not able to do that segmentedly. And also sometimes when there is text inside the image, that doesn't come out right, because I do all of this to generate images for cover letter images for my newsletter, and I had to struggle a lot to get a perfect output out of it. So do you think these are still there, and would these be solved as this technology gets better?
I think those challenges are still there today. And in general, none of these model architectures are perfect, right? And we need to take them as they are. One of the key things to understand about generative models is that they are non-deterministic, as in, I don't have a rule that's always going to give me the same output if I just apply that rule. It's not like a linear equation, let's put it that way, right? But it is their non-deterministic nature that gives such varied outputs. So we have to take, I'd say, the good with the bad. And personally, I have benefited from this variety of output, which some would say it's creativity. I think creativity is innately human, and we just use generative AI models as a tool to materialize that creativity. That being said, there are ways to reduce some of the challenges that we see in image generation outputs. And I've given the example of diffusion transformer models, which basically segment the image in multiple pieces and start applying the diffusion to each one of those puzzle pieces instead of considering the entire picture as one single puzzle piece. That is the problem when you just use a diffusion model by itself. You input the prompt. It's going to have a hard time understanding the relationship between pixels and the prompt to be able to convey an accurate representation every single time. Also, parameters such as parameters or attributes, I'd say, of the image that are usually used in prompts, such as lighting or lighting, or image styles. You've heard, I want this to be comic book style, or there are many there that talk about 4K or Unreal Engine, giving the gaming style effects. Those have different effects on each other. So when you include those, you're thinking that maybe I'm refining the prompt, but you have the risk of ending up with unpredictable results. I do think that the diffusion transform is very promising for the future. There are other options there. Control net is one way to guide the diffusion even more. And think of control net as almost a sketch, almost like a very high level, rough sketch or a map that the model use to generate the image. So then you get some sort of consistency, and hopefully, if you say, I want a shoe, then you are really going to get a shoe and not, a person wearing the shoe necessarily, where the focus of the image is on the person. One of the best ways that I know today to actually control the output is almost combining more traditional ways of editing images with generative AI for images. That means you go through the prompt and generate your first image. And after that, you use tools like generative refill, which I believe tools like Adobe and even Canva today offer to modify parts of the image that you are unhappy with.
Awesome. Yeah, good to know. I know, and I think as this evolves, right, there'll be a lot more applications, right, for people to use in their daily life, right, like creating posts on LinkedIn, social media stuff, marketing, and all of these things, right. So it's much easier to generate multiple versions rather than you sitting and building one in using Canva or Adobe. Yeah, Anita, thanks a lot. I know that you covered this a bit before, but could you go into at least give us some hardware perspective of how do you train a text model versus a image model?
Yeah, well, let's talk about the compute requirements. Training and inference are going to be slightly different. For training both text and image models, and any models, video, audio, need parallel computing due to matrix multiplications. And that means they require infrastructure with GPUs, graphic processing units, or TPUs with high memory bandwidth, because that is essential for parallel processing. Um, then there is the need of high-speed interconnects, such as NVLink or InfiniBand, and that allows for distributed training and reducing the time it takes to transfer the data, and ensuring almost concurrency between nodes, GPU nodes. I already touched on memory. It is the memory bandwidth, but also you need a large amount of memory. For example, for something like a stable diffusion model, you could need something along the lines of 40 gigabytes to 80 gigabytes of VRAM associated with the GPU. And then, the host RAM, the memory that's required to store the large training set. That's one of the key things. When it comes to inference, the focus is more on optimizing latency, or rather reducing it. And there we can reduce things like the needs for memory by compressing the models through things like quantization, for example. Um, and then using inference engines. TensorRT is one of the, say, widely used one, as well as the ONNX runtime. For inference, it's more about low latency hardware and model optimization, as well as scalability. Because when it comes to inference, you will likely not going to be able to predict the workload, or how much how many users you're going to have, right, at one time. But you want to be able to scale to not run into service downtimes, for example, or denial of service. So that's one of the key things. How do you ensure availability of your service to your customers at all times?
Awesome. No, this is great, Anita. Yeah, thank you so much for like walking through all the basic concepts, especially on the image generation side, right? Not many people like very um know as much detail into like what it takes to like build the image generation models and stuff. I'm also like very keen on understanding your journey. Like, can you walk us through your journey in launching your Amazon's first AI generation solutions? How did it go? What was the go-to-market plan, the concept of the market that you had at that time?
Yes, it was. I think we started in late 2022, early 2023, and it was definitely a combination of working back to the customer and moving from the technology, right? Because you have to think of all these large companies. They want to be seen as industry leaders and innovators, especially in AI. So we had to balance the actual customer problem to solve with how do we ensure that we are innovating and at the forefront of technology. Also, when it comes to generative AI, as you probably already know, the field moves so fast that oftentimes the average user may not even know that there's this latest and greatest model or architecture or new adapter that's going to solve a problem for them. So it's very hard to work back from the customer from that perspective. It's more about how do we meet in the middle, right? Get the innovation and start prototyping, and then find the product intercept to ensure that we have the right balance of the customer problem and the solution there based on the latest innovation. So yes, we went through I'd say it was a lot of research and development in the beginning, right? Testing all these technologies, figuring out how they can be applied. And then we had an ideation phase to actually turn it into a solution for a customer problem. For Amazon, it was about lack of creatives. And when I say creatives, think of images used in advertisement today, right? That's an example of a creative at the highest level possible. As an Amazon seller, you may or may not have the skill set or resources to create your promotional content. Especially the small mom and pop shops, they probably can't hire a graphic designer, and they probably don't have the best graphic design skills to go full on with Photoshop. So we thought that was a great customer to focus on to solve their problem, so they can start promoting their products on Amazon more.
No, that is awesome, Anita. So I work for a food tech startup. I see the pain point for sure. Like especially when we talk to restaurants, they want to create like high quality images that can give a very good representation of the food items. But what ends up happening is they don't understand the lighting, they don't understand where to place, what to showcase in an image. And we have used generative AI to a certain extent to create like restaurant like food items, and we have also experimented using that, and we have seen a good success. But eventually, in order for us to like productionize it, that has always been a challenge for us, because when you like try to put those images, they might not be exactly representing the food products, or the restaurants might not be very keen to like use those images to sell their items and stuff. Can you also talk us through like how you went from this R&D approach of like generating these images, eventually like working with the sellers to like get this to the market?
We did create a prototype to begin with, and we validated the early output that we were generating with actual sellers. One of the key things that I want to highlight is that you actually don't need to go and build fancy generative AI product to validate it, right? The proof of concept can literally be pull up Mid-Journey, for example, or even Canva, and create something for a specific seller, for a specific product, using those tools, and see if it resonates with them, if it solves their problem. And then you can start building the solution that is a one-click solution, an automated one that they can use themselves. And then from there on, we had multiple work streams in parallel. Of course, identifying the right models to go with, the training set, and the entire time the focus was on creating the best solution for the customer, reducing friction, and quality. Quality has many dimensions when it comes to images. It can be aesthetics. Is it, aesthetically appealing? It can be relevance to the prompt. It can be correctness. It can be proportions of, because you're generating something for an actual product, right? Like a bottle of shampoo, for example. How are the proportions in the final image of the product versus the rest of the contextual image itself? So those were some of the things that we focused on before launch.
So essentially, you were saying that initially you had this goal of, okay, we want to be the technology leader, and then you went back trying to figure out what would be the best problem we can solve from the customer side. That's when you started, but essentially you said you did some R&D, tried to validate the proof of concept. Is that right? And you validated that kind of using multiple different tools to see if that was the right fit or no. And once you knew it was right, then you started actually building the product. Is that right?
I can't really go into the details of how we built it because of
Okay.
Amazon policy. But that being said, I will tell you how I would do it today based on my learnings. And that is, I would not build any generative AI product or model before I validate a very early artifact based on publicly available free tools. That's what I would try to do. Even if it's manually, so forget generative AI, go and manually cut and paste certain things together, focused on image generation today, and see if they address the problem that your customer has. And then after that, start thinking about the solution and how you're going to build that optimally.
Yeah, absolutely. And I think one takeaway from this would be that you don't need to build the complete suite, the product here, right? You just go back with already, because there are like so many tools out there. You can validate the idea and see if it's the right idea. Is it solving the pain point of the customers? And if you think that is pretty valid, then you can go back and actually build the product, right, for the users.
That's correct, especially because generative AI is so expensive to run. We talked about computational needs, right? And you want to minimize your costs before you know you have a solution that's going to address the customer pain point.
Yep. Actually, another thing, right? So I'm going to talk primarily from a product manager standpoint. So when we try to like launch these 0 to 1 products, or even like any new feature enhancements that we try to launch, we think about the metrics. AI is in a very, I would say, like weird space right now, where you might have to think about metrics on the AI models, like how is it generating, are these actually good images, and then finally the business metrics, whether it's generating value to the customer or not. So how did you guys go about like thinking about metrics, like then validating the hypothesis, and then finally telling, okay, this is the model that's working well?
I'd say for, and I like your differentiation between AI metrics and business value metrics. Yes, for AI metrics, especially when you are in a 0 to 1 space, you kind of have to make them up as you go, right? And then you iterate to improve them moving forward. For example, I talked about quality. There was no benchmark for image quality when we started, especially not in the company. So how do you address that? You put a stake in the ground and say, today, this is the output that is our baseline. And that's the quality. And from that, you start measuring your improvements moving forward. And that way, you create a benchmark, basically. For AI, as things have evolved, more metrics around security, for example, around responsible AI, whether the output is safe for work, whether it showcases some artifacts that should not be there. For example, fragmented watermarks, right? That should not be there. And those are the type of things that you need to ensure when you build an AI-based product. And then, of course, on the business side, I'd say they're more traditional metrics. You do want to look at customer adoption, engagement, especially if it's something like an advertising or promotional product. The engagement is going to be on the viewer side, right? You're running the ad. What's the engagement like for the AI generated ads versus the non-AI generated ads? Is there a difference there? And those are the things that I would say would be good metrics. And of course, retention. Hopefully your customers keep coming back to use your tool if it's a good one.
So, Anita, I know, previously when we were building some of these products, right? I think the biggest concern was accuracy for us, right? Quality, as you said, for images, for text generation, it was accuracy, and it was not easy to measure some of this. So, a lot of time it was initially manual. Then we came up with some automated ways to do that. But what do you say, right? Like, are there enough methods to measure accuracy for some of the outputs that come out of these models now, or are they still evolving?
It depends how you define accuracy. So to me, accuracy is akin to prompt relevance. Is the output faithful to the prompt itself? That's what I would think of it. And that is one of the dimensions of what I think of overall quality. Look, at what you think as quality and what you think of high accuracy is different than what I think of that, right? And it is because we don't have set framework in the industry to say this is how we will define high accuracy, 90% accuracy, for example, or 90% quality. So I think it's important to understand the limitations of the technology that you go with and try to educate your customers as well about these limitations. When you provide a one-click option for them to generate promotional image for their products, it's not going to be 100% of the time of the same quality and accuracy as if a graphic designer that maybe you pay hundreds to thousands of dollars would do and deliver in a much longer time.
That's right. And I think specifically you mentioned accuracy is relevant to the prompt, right? Because a lot of times what I have seen and what others, some of my peers have also seen is that the prompting is not right? People don't prompt the right way to get the output. So sometimes there's a lot of education where you have to give the users how to write your prompts and all to get better outputs rather than just giving some half-baked prompts, right? Essentially. So yeah.
Here's my suggestion for that to solve that problem. And it may not be a popular opinion, but I will say it anyway. Don't give all the controls to your customer, because 90% of them or more are not AI experts and they're not prompt engineers. And you don't want them to be prompt engineers. You want them to just be the users of your product and make that product frictionless. So all that being said, is there are ways to abstract the prompting so that you still take some input from the customer for the actual description of the final image, but you handle it through your workflow in different ways, where in the back you generate the description how you think is best. So you create a solution that 90% of the time, or depending on how you define it, is going to generate relevant, highly aesthetic images based on certain criteria that you employ. And by actually running aesthetic models, I believe Stable Diffusion has one that you can implement. So you can do that. You still give the customer, the feeling that they have some input, but you actually take the heavy lift from them and create the prompts yourself. And you can do that by employing text generation models to generate those prompts.
Okay, so you're actually enabling the end user by taking all of the work on the prompt side inside,
Yes.
and giving them better output. Sounds good.
If I understand it right? So the end consumer want the simplest way to solve a problem. So all they're gonna come and say is, "Hey, I want to generate an image of a cat walking on the moon." But what we are trying to like simplify that on the back end is probably making that prompt much more like deeper by adding probably more details to that, which is what is basically given to the image generation model.
That's right. Well, I'll give you a hint. If you go and look at the Amazon solution that I launched, the prompt is optional. There is no need for prompt from the customer. It takes information about the product itself, and everything is abstracted through the workflow.
Wow, love that. Because you're not even waiting for a customer to give an input, because you know their business, you probably have a lot of details about their descriptions and all of that stuff. Based on that, you can generate them and keep it, and whichever one they like, they can probably use them. Oh, I love that idea. Actually, I want to go deeper, right? So let's talk about go to market, or and the time to market to a certain extent. So let's say you launch this, you probably like piloted with like few customers, and then let's say some few of them loved it, they're seeing more sales and stuff. How did you go about like making it bigger? Like, how did you launch this to the wide audience? How did you make sure, I know your expertise in hardware, like how did you make sure you have hardware scalability available? Because when I think about Amazon, it's like billions of customers, or even when I think about sellers, it's like hundreds of thousands of sellers in Amazon.
Well, yes, we did launch in US only to begin with, right? So we were constrained to one market, which I wouldn't say it made scalability easier, but at least we had some constraints there. Also, not everyone jumps on the AI train. just because a feature is available there, right? It doesn't mean that all Amazon sellers are going to want to use it. But yes, our infrastructure was scalable. It was deployed on AWS. There is an actual technical blog post that I co-authored that talks about the infrastructure and how we used AWS and SageMaker to deploy the solution itself. And yes, AWS has auto scaling as one of the services, so you can employ that as well. But also keep in mind that you need to understand your customer base, right? The customer base for Amazon is huge compared to a company that maybe has, 1,000, 2,000 customers that they need to address. So keep that in mind. And that's how I would think about the scalability solution that you'd need. For many non-big tech enterprise solutions, I'd say that the off-the-shelf scalability offerings from AWS, Azure, even CoreWeave, if you want to get more into the hands-on side of things, those are enough. Of course, look at the implications of cost of taking a service like that versus running your solution on-prem, which means you'd have to manage the hardware yourself. But I would say that for many, the available services by cloud service providers are probably enough.
Yeah, the more you talk, I have more and more questions to ask you. And I see you as an expert in all of these areas. So, Anita, I also see like you have been posting a lot on LinkedIn about all of the AI news, Microsoft Ignite, and all of that. And you told us that you're also starting your blog. So, what inspired you to start sharing your experiences, and what is the blog about?
Yes, thank you for that question. As I move closer to core technology, I want to ensure that I stay up to date to the AI applications that are consumer facing. And for me to do that, I figured that a blog would be useful. It would help me share my experience with others and also help people that don't even know where to start to integrate AI technologies in their current business. It would be one way to do that. So think of it as building, a set of case studies. Anyone that has a business problem, what are the AI models out there that would be built into a solution to address their problem in an efficient and cost-effective way? That's what I'm looking to do with the blog, and I think that will be also solving my desire to stay up to date with the latest technology trends in AI and otherwise. Meanwhile, I get to focus on core technology, much closer to hardware, to enable, in the end, the AI applications, which I think of as customer workloads, to run on the best hardware.
Awesome. And when are you launching this, and where can people go and check out this content?
The blog is launching in December 2024, and the website is thefutureisgenerative.com.
Okay.
Oh, love the title.
Yeah, we'll actually put it in the description so that people can go in and visit and check out your blog. And everybody, please check out blog and leave comments if you have any questions on anything which Anita is talking about today. Awesome. So Anita, I want to switch gears and let's move on to a different topic here. So AI is a great enabler and accelerator in a lot of different workflows, right? But there's also a lot of risk, right? So you see a lot of misinformation, deep fakes, and we have also seen multiple of these debacles coming out. Google screwing, image generation, and all of this coming out in the news and all of that, right? So, what is your approach towards responsible AI?
It's a multi-pronged approach, and I want to preface the answer with there is no 100% effective solution out there today, not that I know of. So that's something that we need to keep working on. And the reason I say that is that any new guardrail or responsible AI technique that gets applied gets outgrown by the latest models that come online on the latest technology. So it's a bit of a cat and mouse game, right? It's new technologies evolve, and the guardrails, responsible AI guardrails, need to evolve as well. There are a few approaches out there today that look promising. One is the content provenance and authenticity approach. That's an industry-wide effort. I think Google is at the forefront of that. Likely Amazon and Microsoft, I think they jumped on it as well. And the idea is that every output has almost like a digital passport, so that we know where that output comes from, which model generated it. That leads me to the next point, is this only works if we have some regulatory information or guidelines out there, right? Because if there's no regulation to say every model has to implement this C2PA type signature, then we're always going to have output whose provenance we cannot detect. Invisible watermarking is another one. And the way to think about invisible watermarking is modification of pixels that are imperceptible usually to the human eye, but that can be detected through algorithms. And that, again, is a form of provenance. We can track where that content comes from. In terms of deepfake specifically, there are detection algorithms out there that are trained to detect synthetic data. And I think deepfakes tend to be more around video and audio, so the data would be more around that. But again, these things evolve so fast that there's probably always going to be one model, one deepfake that's one step ahead of the latest detection algorithm. And we do need to stay informed. Personally, I have been steeping for so long in image generation that I have almost a gut feeling about generated images. I can look at an image and most of the time I can say, yeah, that's AI generated. It's this concept that I call uncanny valley. It comes from robotics, and that's where in robotics, it's almost like the human looks at the robot and it sees that that robot, has a human face, but it looks weird. Something looks off. The blinking is off, for example, and gives us a strange feeling, almost like this is not safe in a way. Similarly, that translates to AI images or video generation, where you can look at that and say, this looks like a really awesome image, but there's something off about it. I can't pinpoint. And that's what I'm saying. I think actually humans are probably the best detectors of AI-generated content.
Yeah, and a lot of times, you kind of get to know when you look at one or two of them and see that it's, you get to know that those are deepfakes. And I think as you're saying, right, as these watermarks get better and better, maybe Instagrams of the world, Facebooks actually make it part of the algorithm, flagging it, saying it could be deepfake and so on and so forth, right?
Yeah.
I want to ask one more question, Anita. I mean, we've watched the Microsoft Ignite recently, and we were excited about some of the products that were launched and stuff. What are your thoughts, and what are you most excited of?
And before you start, right, I also I've seen a post on LinkedIn saying that you some of your team's work has been showcased. If you can cover that, and that'll be great also. Yeah.
I was very excited about the Ignite announcements, especially the ones covering the Cobalt and Maya. Also, Cobalt is the CPU that my team built. It's an ARM-based CPU, and Maya 100 is the Microsoft accelerator that is built to optimize running AI workloads, such as large language models. So these are just great examples of alternatives, I'd say, to compute for AI workloads. And I'm excited to be part of the journey to keep advancing these types of products in the future. And this is where, my understanding of the latest AI technologies comes into play, because I'm hoping that I can inform some of the roadmap to focus on enabling the workloads of tomorrow.
Awesome. So could you maybe tell us more about, if it's okay, about your new role? That's you leading the hardware transformation at Azure.
It's an ambiguous role, so I can't say too much about it other than it's finding problems and ways to solve them, hopefully by integrating technologies such as artificial intelligence. That Azure hardware infrastructure in particular is positioned in a way to meet the business demands and AI or otherwise workloads of the future. That can mean improving operations, for example, through automation, through AI. Obviously, hardware infrastructure is in large part in the data center. So, how do we find ways to reduce downtime for customers? That's an example of a problem that I'm focusing on.
Awesome.
That's great. Probably like little bit more deeper. Let's say if someone wants to go into Azure in the hardware side of the generative AI, what are some of the tips that you could give for anyone like who's stepping into it?
Oh, hardware and generative AI. Personally, I don't think that they are close together today, unless you are, maybe working at NVIDIA, because they are entrenched in the space. I'd say, right? But I'd say definitely an understanding of hardware architecture and in general, what does it mean to enable these AI workloads on hardware. So going back to what I talked earlier around the compute requirements for training or inference, that familiarity would have to be there to start with. And then of course there's opportunities. If you do not have to be a hardware architect or a hardware engineer, you can focus at the software framework level, for example, right, where you are enabling these workload applications to run in the inference time.
All right. Yeah, let's maybe end with a quick rapid fire with a couple of questions, right? So, what's your favorite book on AI or product management?
That's a tough one because the space is moving so fast. So books that were published last year, they may not be as relevant today. That being said, I really enjoy Coming of Age by Mustafa Suleyman. And the reason for that is that it's a very thought-provoking book. It doesn't go into details about specific technologies or model architectures, but it talks about the implications of AI on ethics and security as examples, right? And for me, certifying the application for Amazon through the security process was one of the biggest learnings I've had. So that is very close to my heart. And I like to stay informed as to the implications of cybersecurity. And I really think through how does the threat model change for a generative AI application versus a regular one? Because it's a different ballgame, right?
Awesome. Yeah, thanks a lot, Anita, for so much of wisdom and knowledge around all of these things. This is something which we have never covered on our podcast. So anybody who wants to reach out to Anita can reach out on our LinkedIn, and we'll also provide the link to the her blog in the description. So please check that out, and also please comment if you have any other questions to her. Awesome. Thanks a lot for being on the podcast and taking time to talk to us.
Thank you for having me. This was great.